In this lesson, we're going to focus on graphing the solutions to an inequality on a number line. To begin, we need to talk about what an inequality actually is. And there are four symbols that denote that something is an inequality. One of them is the less than symbol, the less than or equal to symbol, the greater than symbol, and the greater than or equal to symbol. And what these essentially state are that one side of that inequality could be bigger than the other. So just to kind of remind you, in case you haven't seen inequalities in a while, I like to think of inequalities kind of like a Pac-Man mouth. So if I were to draw the less than symbol and go that way, there's my Pac-Man mouth. And I like to think of it as my inequality is a Pac-Man that likes to eat, just like the Pac-Man game. So the inequality, the open mouth part, is always towards the side that will be potentially bigger. So to begin, you need to know how to read your inequalities. The open mouth side is the side that will potentially be bigger than the other side. So here I'm going to label each, noticing that the open part is the side that is intended to be bigger, and the other side is the side that is intended to be smaller. Now, you also need to notice in here that there are less than and less than or equal to is greater than and greater than or equal to. These lines say that the two different sides could be equal. However, in these, they will not ever be equal. So make sure that you understand your inequalities and how to read an inequality statement, which side should be larger, which side should be smaller, and if those two sides could potentially be equal. Now, technically when we solve equations, we could in fact use a number line in order to graph our solution. So here, in the first example, we see x is equal to 5. If we wanted to actually graph this solution on a number line, so I could label and say this is 5, 6, 7, 4, 3, and 2. And I could say x is equal to 5, put a closed circle here at 5, and call it a day. So that would be my solution to that equation. The one equation solution I have is x equals 5. Now that's a little silly because we're just plotting one point, but we can do that. Now when we're looking at inequalities, the use of a number line can actually be very powerful, as this actually represents an entire set of numbers, and we can represent those pretty nicely on a number line. So this is saying that x could be anything, so x could be anything less than 4. That's what that statement is saying. If we pick an x value, anything less than 4, that value will make that inequality true. So when we're plotting this on a number line, we're plotting all of the possible values for x. So to start, I always look at, okay, we have x is less than 4. So I always put 4 in the middle, and then I put some numbers above it, and I plot some numbers below it. Then from here, there are two different circle options that you could potentially choose from depending on your inequality. So you could have an open circle, so notice that this is open, and this is used for less than and greater than. Essentially what it means is that the number where the circle is will not make the inequality true. We could also have a closed option, so it means we're closing in our circle, and this means an or equal to, because this means, okay, the value of 4 could make that inequality true or something like that. So first we have to decide what type of circle we have. And if I look at this one, I just see a less than symbol, so I know that I have an open circle at 4 to indicate if I put 4 in for x, so 4 is less than 4, that would result in a not true statement. That's what that open circle communicates. Then from here, we're going to include an arrow on our number line in order to indicate all of the values for x that will make that inequality true. So if I'm looking at my number line, I know that values like 3. 3 is less than 4. That's true. Values like 2. 2 is less than 4. That's true. 1. 1 is less than 4. That's true. Those values make the inequality true, and as a result, I'm going to graph my number line and put an arrow pointing that direction to indicate that the values to the left of that open circle are the ones that will make the inequality true. So here are 4 examples we're going to walk through quickly. So here we see x is less than or equal to -2. Because of that equal sign, I know I have a closed circle. And then I'm going to put my -2 right in the middle. I then here have -1, 0. This way goes -3, -4, etc. So I'm going to put a closed circle at -2 to indicate that 2 would in fact make that inequality true. And then I need to point my arrow towards all of the numbers that are on the smaller side of -2. Now this can get a little confusing with negative numbers, but I know that -3, -4, -5, those numbers are all smaller than or equal to -2, so my arrow needs to go to the right. Now if I look at the next example, I see that x is greater than 5. That greater than tells me that I have an open circle because there's no equal to underneath. I'm then going to go to 5, label a couple of extra numbers around on both sides, put my open circle at 5, and then I know that I need to point my arrow towards numbers that are on the bigger side of 5. So 6, 7, 8, etc. are all greater than 5. So I need to point my arrow towards those numbers. Now if I look down at number 5, I see that I have a less than or equal to sign, so that means that I have a closed dot at -3. I'm then going to add a couple of numbers on here, and then I put my closed circle at -3. Now, this one is a little bit tricky because the x and the number are flipped around, so this is where you really need to understand how to read an inequality. So here I can see that x is on the bigger side of -3. So what that means is x needs to be a number that is bigger than -3. And I know that -2, -1, 0, those numbers are all on the bigger side of -3. So I need to point my arrow towards those numbers to indicate that x is larger than -3. And then the last one here, I see x is less than 4. So I go to -4, I pick some numbers on both sides. I know I have an open circle because there's no equal to underneath, and then I need all of the numbers where x is on the smaller side of -4, so that's numbers like -6, -5, etc. Those are all smaller than -4, so those would be the numbers I could replace in for x to make the inequality true. So here we're now going to actually write the inequality for each number line graph. And what you should be noticing is that they all have some sort of relationship with 1. So we're going to have x related to 1, x related to 1, x related to 1, and x related to 1. And what we need to decide is what symbol is going to go on the inside there. So what I notice here is that I have a closed circle, so that means it's going to be less than or equal to 1, or greater than or equal to 1. And then as I look, I notice that we're heading towards numbers that are bigger than 1. So what that's telling me is all of my x values are on the bigger side of 1, and then the equal sign underneath for the closed circle. This next one, we have an open circle which tells us less than or greater than. And then I notice again we are heading towards all of the numbers that are bigger than 1. Then I go down to the third one, and I notice this has a closed circle, so it's a less than or equal to or a greater than or equal to. And then from here I notice that the number line is going towards numbers that are smaller than 1. So we have smaller than 1, and then the equal to included. And here we have an open circle, and we're heading towards numbers that are smaller than 1. So it's that less than symbol. So you first start by looking and noticing if you're going to have an equal to or not, and then look at the way at which the number line is pointing. Are those values becoming larger than your dot value or smaller than your dot value? And finally, we're going to look at a couple of different word problems just to make sure that we can utilize our inequalities when we read a situation. This one says the temperature T in Sweden is at least negative 10 degrees Celsius. So I know that I'm comparing T and I'm comparing negative 10 degrees Celsius. Those are the two items I'm comparing. And I'm saying the temperature is at least negative 10 degrees. So if it's at least negative 10 degrees, that means that negative 10 is the smallest the temperature will be. So when I'm thinking about that, I want my temperature, so my temp is bigger than negative 10 degrees. So reading that, I can now put that in and say my temperature is negative 10 degrees or bigger. Then if I look at the next one, it says the elevation E of Alabama is at most 2,407. So at most means that 2,407 is the largest or the tallest. We can put tallest that it will be, the highest it will be. So that means that E is 2407 or less. So here we can do less. Now for each of these you might be wondering, should I have an equal to underneath? And typically in this type of situation, because we're saying at most, it means that it could reach 2407 or be less. So yes, we want to include an equal sign. Or in this one, we could go down to negative 10, that should be included. Otherwise, we'll be above it. So yes, you should include those equal signs in both of them. At most and at least are implying that equal sign underneath. And final two examples. At the lifting competition, is what that should say in there, the amount Jordan benches B is no more than 175. So we're saying B is no more than, which means it can hit that, it can hit it, or be less. So that means that the amount we lift, which is right here, the amount Jordan lifts, needs to be less than 175 or equal to it. Then in the next one down below, the temperature in a pool P must be no less than 76 degrees, which means it needs to be 76 degrees or higher. So then if I think about it, I'm going to be higher or equal to. So there you have it.